faster than the fabric of space-time can keep up with it. And it'll just rip. And I'm terrified by it.
A star in the distant night sky is undergoing changes that will alter its appearance significantly within decades, if not mere years. Astronomers and experts, including Neil deGrasse Tyson, have sounded alarms about the imminent explosion of our beloved North Star, Polaris. Its prominent role in the night sky, particularly as a North Star, adds a disconcerting element to the narrative. Join us as we explore the details of Polaris explosion and its impact on our planet. Polaris is on the brink of explosion. Polaris is on the brink of explosion, and there are already indicators pointing towards this eventuality. As a Cepheid variable star, Polaris has consistently displayed seasonal variations in brightness, providing scientists valuable insights into the nature of variable stars and stellar properties. This periodic fluctuation in brightness has been instrumental in understanding cosmic distances and calibrating instruments. The predictable patterns of these brightness pulsations observed in stars like Polaris facilitate straightforward predictions. In recent times, there are indications that Polaris is deviating from its established behavioral pattern. Instead of the anticipated cyclic pulsating brightness, the North Star now exhibits irregular pulsations. Astronomers find themselves puzzled by this recent shift and have opted to conduct a more detailed examination of this irregularity. Polaris presently emits light erratically, dimming before its usual time frame. Scientists are raising an alarm as this behavior mirrors how stars typically behave when approaching the end of their lifespan. For an extended period, Polaris maintained a stable pulsation period, potentially spanning billions of years. Similar to other stars, scientists attribute the periodic dimming and brightening to interactions occurring between star systems, appearing as one from Earth. It is observable that Polaris experiences an annual increase in pulsation of approximately 4.5 seconds. Regarding the cause of this unanticipated change in Polaris's behavior, scientists are divided into two camps. One group suggests that gravitational movements between Polaris and other stars might be accountable for fluctuations in the North Star's atmospheric conditions, leading to irregular pulsations. The opposing camp dismisses this theory, firmly believing that the North Star is on the verge of exploding in the near future. The second camp's conviction is rooted in the resemblance between Polaris's recent behavior and that of Betelgeuse, a prominent star in the Orion constellation. Betelgeuse displayed irregularities in brightness, sparking speculations about an impending explosion. Given the shared luminous fluctuations between Betelgeuse and Polaris, scientists are actively disseminating warnings about the imminent explosion of the typically stable North Star, Polaris. Drawing insights from Betelgeuse's experiences, scientists can anticipate the eventual fate of Polaris. All Cepheid stars manifest similar irregular pulsation patterns in brightness as they approach the twilight of their life cycles. Before reaching this stage, these stars consistently exhibit periodic pulsations over vast eons. Polaris, like its stellar counterparts, will undergo alterations in the pulsating brightness, signaling the culmination of its life cycle. In contrast to the apprehension sparked by Betelgeuse's erratic behavior, the outlook toward Polaris's imminent explosion appears to be one of composed vigilance and keen interest. NASA has yet to officially address Polaris's fluctuating pulsations. As Cepheid stars progress through their evolutionary stages, a normative trajectory unfolds. Originating as nascent stars with low brightness and relatively cool temperatures, they undergo nuclear fusion as a pivotal phase in their evolution, maintaining stability for billions of years. Approaching the conclusion of their life cycle and with depleting hydrogen fuel, they transition into the red giant phase, marked by a significant surge in brightness and temperature. During the red giant phase, a notable burst of energy occurs, leading to a cataclysmic explosion, commonly recognized as a supernova. This explosion sheds the outer layer of the star, unveiling a spectacular and radiant display. Post-explosion, a compact, dense core remains a white dwarf, a poignant relic of the former Cepheid star. With Polaris currently exhibiting erratic pulsations, scientists predict that the star is undergoing its helium depletion stage, a common occurrence in Cepheid stars approaching the end of their lifespan. As a Cepheid star depletes most of its helium supply, it experiences irregular pulsations, causing fluctuations in brightness. As the helium supply diminishes further, it results in irregular and uneven light emissions, a characteristic reflection of the helium depletion process observed in stars approaching their twilight, including Polaris. While Polaris demonstrates these typical Cepheid star behaviors, there is no definitive evidence indicating that it has reached the end of its life cycle. Nonetheless, these irregularities are subject to ongoing study for a more comprehensive understanding of Polaris's culmination. In the event of a supernova occurrence in Polaris, it would be a striking phenomenon, impossible to overlook, as it would create a dazzling spectacle in our night sky. Polaris's brightness levels would dramatically increase, potentially surpassing the Moon's luminosity for days, weeks, or even months. The star's appearance might manifest as a remarkable burst of light in the sky, exhibiting temporary hues before gradually fading away. This supernova event could potentially impact the well-known position of Ursa Minor due to Polaris's current role as a North Star in the constellations. Earth's response to a Polaris supernova. All signs point to Earth remaining secure in the event of a Polaris supernova. Given Polaris's distance and mass relative to our planet, while the explosion may not rival the spectacle of Betelgeuse, it would still be observable with the naked eye for an extended period. Observers, the global scientific community, stargazers and astronomers alike, would witness this phenomenon with quiet wonder. The impact on Earth from a Polaris supernova would be less pronounced compared to a supernova occurring in closer proximity to our planet's surface. Polaris's destiny after explosion. Although supernovas typically signify the end of massive stars, it's improbable for Polaris to undergo a colossal explosion resulting in a neutron star or a black hole. Massive explosions typically occur during a giant star's supernova, marking the final catastrophic stage in the star's life cycle. The emission of heavy elements during this process can lead to the formation of neutron stars or black holes. Neutron stars emerge from the complete collapse of the core of a high-mass star, while a black hole is an infinitely dense celestial object with an intense gravitational pull capable of trapping even light. Due to its insufficient mass to trigger a supernova, Polaris will not transform into a neutron star or a black hole. With a mass only 5 times greater than the Sun, this Cepheid star lacks the magnitude required for a supernova. Instead of undergoing a violent supernova or explosion, Polaris will gracefully shed its outer layer and transition into a white dwarf after exhausting its nuclear fuel. This transformation will unfold peacefully, avoiding the turbulent tendencies associated with a supernova as it evolves into a compact, luminous remnant in the celestial expanse. White dwarfs are stellar remains of stars of medium or low mass that have exhausted their helium or nuclear fuel. These dwarfs are so dense that, in their true size, they're as massive as the Sun. However, they're now compressed to the size of the Earth after collapsing under their gravity. Because there's no more nuclear fuel to sustain it, astronomers and stargazers would no longer be able to spot its remnants from Earth, just as they currently see it as a stable and consistent star. The impending signs of Polaris's explosion and past star explosions could offer valuable insights. Though Polaris isn't likely to explode, analysis of recent supernova experiences like SN 2014J or SN 2011F can provide decent metrics for comparison. When you study the spectra, light curves and remnants from these events, and then use your study to see how far Polaris is to the culmination of its lifespan, the present evolutionary stages of the North Star can be deduced. Just by comparing its current signs with the signs experienced by past supernovas, scientists can go even further to analyze the differences in mass, speed, and composition between Polaris's obvious bursts and past supernovas, assessing the pulse variability of different stars advancing to the end of their life, like Polaris, against past stars who have completed their full evolutionary cycle, can help scientists measure deviations or similarities from established signs. Since the inception of humanity's exploration of stargazing and astronomy, Polaris has held its position as the guiding North Star for researchers. Its unwavering presence in the night sky, coupled with its consistent location near the North Pole, amid the dynamic celestial backdrop, has established it as a navigational beacon for those observing the night sky. Despite current indications of Polaris approaching an explosive phase, the exact timing of its eruption or transformation into a white dwarf remains uncertain. This uncertainty stems from the fact that the North Star is situated 323 light-years away from Earth. Consequently, any observation of its explosion on Earth will only occur 323 years after the actual event. Thank you for tuning in. Remember to like and subscribe for more content like this.